Hello, and welcome to Automat Live Coding. We are not going to be doing a lot of coding today. I am also not going to introduce Automat in depth. Or maybe I will. I mean, I'm showing this every stream, so let's just do a quick demo. This is Automat, right? So what I wanted to do today, instead of regular coding, is first of all, I'm going on vacation, 1.5 months. So I will be back on September 17th. And I want to use this stream before this longish vacation to do a retrospective, to take a look at the stuff that we've done over those first 3 quarters. I mean, they haven't ended yet, but I think it's a good point to take a look back and to adjust our plans for the future. So, before the stream, I went through my YouTube history of all the streams that I've done for the past 8 months, and I counted. What have we been doing during all those streams? And I came up with some interesting results. One thing that, the thing that we started the year with was lag reduction. We had issues in Automat with just general slowness. As we were adding more objects, just dropping a couple objects on the canvas was causing the rendering to get slower and slower. It was especially visible for those key objects. They have a fairly complex rendering logic, or hotkeys as well. And after, for instance, at this point, Automat would be barely responsive. So actually made it work. We made it work pretty well, I would say. Zooming is still not super optimized. We still get some lag during zooming, but you can see that there is this pixelation effect when I zoom in very quickly. It's there just for a couple of frames, but this is what's making the rendering smoother. We can render incomplete objects, and this is a big deal. It made the UI feel nicer. I've split this lag reduction arc into several sub-arcs, let's call them. One was about multi-threading, latency hiding, Vulkan, and migration to Graphite, which is the new rendering backend in Skia. And none of them pops out. I experienced Graphite migration, I think, more than it actually cost. And this whole project, say mega project, this whole latency lag reduction, in total, it took us 21 streams. So 21 streams is 7 weeks, almost 2 months of work on just reducing the latency, and I feel that we are still far from being done. We just recently added tracing, and it's clear we have a lot of long hanging fruits still in the rendering layer to address. When I look at Tracy, at how we are utilizing the CPU cores, it's far from 100%. It's like we are still working mostly on a single thread, and multi-threading only kicks up during a very small part of the rendering process. So it's going to get a lot better. The potential, the ceiling is very high. We could make rendering about 10 times faster. There is easily an order of magnitude left to optimize. So that was one bigger project. Another bigger project was machine code scripting, so assembler. So now we can use this assembler to store text. Oh, it's slightly buggy. So if I first, for example, increment a register, I can then maybe double it. If I run this a couple of times, you can see that each time I'm doubling the register value, it changes. I'm gonna position it like that. Let's hook it up in a loop. So now we can see the flag is shifting up. So this project, this assembler thingy, yeah, we're out of range, took us a whopping 34 streams. Converting this to weeks, it will be like slightly more than 11 weeks. This is almost 3 months to make this happen. And this machine code scripting, it doesn't feel great because it doesn't feel complete to me, because we don't allow the user to access SSE instructions, like, SIMD instructions in other way. And we don't have flag visualization. I wanted to visualize the flag register. It's missing. And we don't have any instructions that modify memory, so no stack. So I don't feel that this assembler is complete until we have those features. So even though we've spent a lot of time on this project, it's still, not far from being complete, but we will need many more streams to actually finish this, and many instructions are still so many instructions are just describing text, which is not great. We could improve it. We should improve it. So I would say that I still haven't seen a payoff of this assembly, of this machine code scripting. Yes, it can be used to do some logic, but I feel we could have spent this time on actually creating the missing objects on an ad hoc basis. So, like, for instance, a loop object, a condition object, those kind of things. Those basic control flow objects that are missing and that have to be implemented with assembly right now. So this is missing, but it kind of works. So it can be used to do stuff, and it looks kind of cool when it does stuff very fast. The fact that it's implemented in the actual assembly and it's actually executed on the CPU, it's not practical, but it's just cool. So there were a couple of streams that went purely to eye candy, like adding cooler themes, adding a wave animation in some of the instructions. So if we look at some conditional instructions here, for example, this whole widget, the fact that it fills with water when we are on overflow, and that the water, or like it spills when we are here, and the water it's animated like that, and that we can drag it in literally any order, any direction. We can scroll it however we want. It's kind of fun. It's totally unnecessary. We spent just 3 streams dedicated purely to eye candy, so this is not a lot. And it kind of looks fun. It's the stuff that we worked on is maybe not super visible in Automat, but there are some places where it's there. We spent 2 streams playing games. Those were mostly, I think this was Skyrim. 9 streams working on the window capture object, which is actually pretty decent. Actually, this object it still has bugs on Linux, especially because on Linux when I start it, it will lag the Automat. Now Automat is very laggy. There is just I didn't still do proper multi-threading on the Linux window capture. On Windows, it's going to work nice. I have to stop it, and now it's responsive again. We also have this Tesseract, which can connect to this pretty nicely. And if I run it, it can recognize text. I can D3. Nice. OCR took us 5 streams, window capture took us 9. Surprising, because I thought this OCR will be harder. It's not super fast, but it works, it gets the job done. Then Bubble Menu. I've spent 2 streams working on this Bubble Menu, and it can be used to do stuff. Like moving the objects, running the objects, deleting the objects, not much. So in terms of time well spent, I will rate them. I would say Bubble Menu is A. That actually turned out very well. OCR and window capture, super nice. Playing games also was valuable because this helped choose the next steps, essentially. For eye candy, I will say B, because the eye candy that we worked on are very deep in Automat, so they are hard to discover. So I'm not counting the eye candy, which is kind of all over the place, or like this moving eye or other things like that. I'm talking about Easter eggs. Okay, maybe let's call them Easter eggs. Machine code scripting. Was this a good use of the time? I would say B, because it took a lot of time and it's still not finished. Lag reduction. In terms of lag reduction, this classification doesn't even apply because lag reduction was necessary. We had to do this. Okay, then we had a couple of streams on infrastructure. So things like adding Tracy, switching to like making a new website. And since those are just 3 streams, I would say it was super valuable to actually spend some time addressing those issues. We've spent a couple of streams working on the timeline widget. I'm not counting specifically mouse traces, just bug fixing. It's a rather complex widget. It has a lot of internal machinery that has to happen to make it work. It actually has nested objects inside those tracks. Each of those tracks is a semi-autonomous object within the timeline. this snapping, zooming, all those things. It took us a couple of streams. Still, timeline seems to be a very central piece to Automat. So I will still rate this as a night.
Zephyr Book says.
So there was one other feature that we added that was very small. There was no dedicated even stream about this. It was about picking up objects. So the fact that I can pick up a timeline which is on the bottom and it automatically picks up all of the objects which are in front. That was such a simple thing to implement. Hey.
TT Chica says.
Mr. Sir.
So that was such a simple thing to implement, and it brings us so much utility that I think I will reduce the the benefit of all of the other things just to say this is A, because the trade-off between time spent on this single thing versus the improvement in usability is just incredible. And I will actually rename this. This was stacking objects, but this was really a gesture, implementing a new gesture. And I would say Bubble Menu also belongs to this category somehow. So let's say we spent 4 weeks on new gestures, 2 of which were spent on Bubble Menu, 2 of which were spent on stacking objects. And overall, I would say this is probably the best use of the time, implementing those new, not specific gestures, not something like, for example, this drag operation, something that can be applied anywhere in the user interface, universal gestures. Then we also spent 9 streams working on mouse capture, which again is still not finished, it's still buggy. It works, but if I, for example, tried overwriting some of those gestures by re-recording over this timeline strip, that would cause issues. So mouse capture is still incomplete. Actually, nothing feels complete. And so the things that went well: stacking of objects. It feels great, it's super intuitive, it just works. And it also produces very compact machines, because you have to kind of stack everything and you have to identify the bottommost object, the central piece of the machine. It leads to a very nice pattern of use, and it's very new, like no software does this, but it's very fun also. I will also say that the Bubble Menu we are not using it really, we are using Bubble Menu, but we just have like 3 or 4 options, and maybe the assembler has also some, right? So I would say that we are not utilizing the full potential of the Bubble Menu, but Bubble Menu is a gateway technology. So it opens up this open-ended interaction mode where an object can theoretically have like infinite number of actions attached to it. Okay, so what didn't go well? There is one more thing. In addition to the fact that nothing feels complete, there is also the fact that implementing every single object takes so much time. Like mouse capture, 3 weeks plus. So I would say we will need at least a month. So implementing a single object requires approximately 2 months of work. Which is, if we extrapolate this into the future, it doesn't look good. It doesn't look good because it means that like, for a year of development, we can get like what? 6 more objects? Like well-designed objects, true, but it goes so slow. And those objects, they require fixes as the underlying infrastructure is changing. So this is something that we have to address. We have to figure out how to implement objects which feel complete, which feel done, and how to do this way, way faster. 2 months is just crazy amount of time. It has to take a day. Like implementing an object has to take a day. So let's set some goals for 2025. So the goal for Automat is to automatically play games. This is the MVP. This is what it should do. This is what makes it useful. So bringing it to this point, I think this should be the priority. So no more bugs, no more random crashes, half-implemented features. We have to focus on the basics. So we'll not work on gamepad recording. Actually, we will not work on assembler in the meantime. Instead, we will focus on great macro, like macro recording has to just work, it has to be amazing. The objects for manual composition of objects also has to just work. So we shouldn't have inconsistencies, for example, between key presser and mouse up and down, which they follow slightly different modes of interaction. They also have different sizes. So this and this, those two have to be polished. And there is one more thing that is really necessary. Let's call this Chrome of Automat is still lacking. So Automat is this window, white window with a canvas that you open and that you use, but it doesn't really play well with the rest of your desktop. If you want to actually record a macro, you probably want to minimize Automat and record it from the background without this whole thing, without this whole window. So by being more usable, I mean it should be minimizable to tray. Actually, Automat should live in the tray. The tray should be the place where basically where you interact with Automat the most. Opening the window, you open the window only when you actually want to work on designing some machine, but then once you're finished, you minimize it to tray. You shouldn't be really interacting with this UI at all. It should be operated from background using keyboard shortcuts and this tray icon. And it's not there, so this is something important. Another thing is that when Automat runs, it uses some amount of CPU in the background and for rendering, because it's constantly refreshing the window. It's a tiny amount of CPU. It's comparable to Chrome actually. So if you open a Chrome, right? Chrome constantly refreshes itself, for example, to refresh the cursor. So it keeps waking the CPU. I don't think Automat should do this. I would go for 0 CPU usage when idle. So when you're not using it, you shouldn't be paying for having it in the background. So those three things will be the focus for the rest of the year. I mean, after I come back from vacation. When I go to vacation, I'm not going to do any coding, but I don't mean optimize it a little bit so that it's a little bit faster. There are some dead ends, like tooling improvements, like any sort of improvement that's, 10%, 20%, or even like 2x. This won't cut. The only solution is something that will actually make it asymptotically faster, like the approach for writing new object has to change, basically. So potential solutions are like LLMs are one. If it's possible to have an LLM generate a new Automat object end-to-end, including design, including coding, including testing, then that's going to be a win. Because if we can automate object development, then we can leave a couple LLM agents in the background, tell them to implement 10 or 20 different objects, and they will do it. So even if they take, a couple of days to implement a new object of constant, work, we have computers, right? We can leave them running in the background. So this could work. Another approach is hooking into external ecosystems. So there is a lot of software out there. We don't have to implement everything from scratch. If it's possible to, for example, to expose all of the Python. So if it's possible in Automat to hook into all those existing libraries, those are enormous libraries of software that's out there that can be just invoked basically from Automat. Or HTTP REST APIs. Then a couple well-designed objects could, in theory, just make Automat drastically more usable. If we can hook into native C libraries, then it should be possible for a user to create a restreamer, FFmpeg, anything, literally anything. If it's possible, then all of the work that we've done implementing window capture our work working on window capture and Tesseract becomes obsolete, because if the user can hook into those libraries and expose this as nice objects, yeah, then it's going to be even better. Lastly, there is one more approach that could work. And this is designing new Automat objects within Automat. Because if this is possible, then it's possible to create a, let's say, Automat's sort of package repository. So, like sharing between users. This is a Pandora's box. I will. So I'm a little bit skeptical about this, but I will consider whether this is. I mean, it's obviously possible, but whether it's worth prioritizing this over the other ideas. But it is very clear that next year we will work on one of those. We will try to make object development 10 times faster or 100 times faster. If it's possible, it's going to be pretty cool, and the development pace is going to accelerate. So yeah, I'm not going to stretch this much. I don't have many ideas. This is why I'm kind of recording this. I will think about this when I'm offline. Yeah, just looking again at the list of conclusions. Yeah, I guess this is it. I'm thinking about this, and when I get back, I will let you know what we will do next year. Okay. Again, I shouldn't stretch this. So, see you in a couple of months. Not couple of months. See you in September. Bye bye.